Okay, there we go. So I'm just trying to get to the most current log so that we can see this, but I just want you to see this in action. So I'm just telnetting out on port 9001, and you can do this as well, right? Once you turn off that outgoing policy, it doesn't matter, you can pick a port, but we can see a deny message, right? That just pops its way through my log lines, and we're denying traffic on port 9001, and here it is. This is that unhandled internal packet. It's that hidden policy. That what that means is that this packet made its way all the way through the list, right? Because it's looking for port 9001, and it said, nope, this is 2180, 443, 8080, the ICMP protocol, port 53, 4105, 1718, and this is disabled. So there's no policy for port 9001, which means the only policy left to handle that traffic was one of the two unhandled packet policies, but since this arrived at my Skynet interface, right? So if we kind of follow our log line, you see the disposition is, you get your time date stamp, and then allows are in green, denies are in red. The source IP address is in white, the destination IP address is in yellow. Then you get your port / protocol, right? So it's on TCP 9001. Then this first number here in white is your source port. That's used for network address translation tables. We'll talk about it tomorrow. And then the second number is your destination port. The destination port is what everybody's talking about when they're like, oh, DNS travels on port 53, the HTTP is port 80, right? All of that, HTTPS is port 443. All of that is destination port. Then you have your source and destination interface. And so that's just it. That the reason that this was handled by the unhandled internal packet policy is because the packet arrived at an internal interface. It arrived at Skynet. Right, it was being denied because we don't have that open, so it's the internal side that handled it. You'll see that here's one from the external side, right? And this is actually just noise on the virtual network that's bleeding through with SkyTap. But nonetheless, it facilitates me being able to give an example that you can see this unhandled external packet that's coming from some random IP address that's arriving at my external interface, right? So as far as all the virtual interfaces we have, this bleed through is coming through on the external side to my Firebox. And my Firebox is doing its job. It's just being like, denied, nope. But it's being denied by the unhandled external. So arriving on the outside versus arriving on the inside. So now it's just a matter of making policies for all of your traffic, right? And please understand that by turning off this outgoing policy, you have just increased your workload a hefty bit at first, right? I mean, you just closed off a bunch of ports, and the fact is that in real world environments, they need more than just port 80 and 443 and port 53, right? They need more than just the internet, and likely more than just FTP. There's going to be random obscure ports. There's going to be business applications. There's going to be all sorts of needs and uses for all sorts of other different ports and protocols. And you're going to have to play that game of tweaking the firewall. But the best way to do this, the best practice for that, is to understand and go into it, that, okay, we've got a ticketing system or something set up that for the first week, maybe 2 weeks, worst case 3 weeks of this, firewall installation, there's going to be some trials and tribulations, right? Week 1 is going to be the week where we're really going to refine most of it. Week 2 will trickle out a little bit more, and if necessary, with a week 3, it could continue out, right? Because most actions that are business critical are going to happen on the daily. So within the first week, you should get most of your tweaking taken care of. Some things maybe only happen every other week or maybe once a month. So those, you may only run into them at such a time as they occur. Maybe there's a few things that trickle out that are quarterly. And so all of a sudden you're like, oh, you don't find out for 2.5 months that there's one more tweak that you need to make, right? But that first time, we just need to make sure that we're taking the time to get everything opened up and define what is necessary, right? So I'll get into all the services and the proxies later. I'm looking at the fundamental, just ports and protocols level first and foremost, right? When it comes to building policies, first of all, I'm a huge proponent of what I try and call conscious policy creation, right? For example, when I'm going through my policies, right? This is a common default for a lot of people is when they set up a policy that, and add a new policy. And let's just say that I need this policy. Doesn't even matter what it is because I'm going to delete it anyway. I'm just kind of making an example that they're like, boom, I need it to go outbound. And this says any trusted to any external. Perfect. Sweet. That's what I needed. When in all reality, they had a Citrix provider. And the Citrix provider is like, oh yeah, we need you to dial out to us. And we need you to do that over port 1494, just our standard Citrix port, right? And we need you to call out from your Citrix server out to our upstream server at our hosted site. And here's our URL, right? Or here's our friendly fully qualified domain name that you can call out to for our Citrix use. And so really, in this little story of mine, I actually have one computer that needs to be able to call out to one destination for one specific purpose, and then my internal server handles all my host computer clients. Or maybe I need to have my entire Skynet network send out to my Citrix provider, but it's still only calling out to one destination. So rather than just opening it and be like, yep, it's open, let's actually take the moment to, be like, wait a minute. In my scenario, it's either, I can click add here, and instead of just any trusted, maybe I made an alias for that special Citrix server computer that needs to call out to the Citrix domain. And so I've got an alias for my Citrix server. Or if I don't have an alias, there's this very cool and very oft used add other button, where now I can just input a host IP or a network IP or a range, IPv4 or 6, a fully qualified domain name, right? So custom addresses, device groups, like there's all sorts of different ways we can list this. And so what if this was my Citrix server? And again, I'm making up this IP address. Obviously, I do not really have this Citrix server. I'm just kind of filling in an IP address within my subnet to kind of complete the story. So source 10.0.200.88, right? Because that's really the device in my story that needs to call out to that Citrix destination. And moreover, it's not just that do we need to open up port 1494 to any destination out there on the internet? No. Right? Again, I don't have an alias for the destination, which is this Citrix hosted provider, but I would need to, come here and say host IP address, or instead of that, maybe a fully qualified domain name that's hosted.citrix.provider.net. I don't know. Just kind of making it up, right? But maybe that's who I need to call out to. So why not do that? Already, I've made my firewall so much more secure by, instead of opening up port 1494 to the outside world, just wide open, I'm pointing it to the destination that I actually have this traffic, right? I've talked to the people that are trying to send this traffic, because the problem is that they complained in the first place because traffic was getting blocked on port 1494. Okay, so I'll have the conversation with them. Be like, okay, what is going on? What are you trying to do? Oh, well, we're sitting off this Citrix stuff, and we've got this thin client that needs to do this thing, and it's really cool, and blah, blah, blah. Great. So where does this traffic go? Like, do you need to call all over the place? Or, oh, no, I'm like, we've paid a hosted Citrix provider. Epic. Where do they want you to dial to? Oh, this. Perfect. So do all of you call to this? Or like, no, we get our own little hosted server, and then we can all dial into that. Epic. What's the IP address of that server? Right? You kind of work through the story so that you understand what it is that needs to happen. Maybe they're like, no, it's not a server. All of our clients call on, but all of our clients are coming from Skynet. Right? And so now I'm just listing the 10.0.200 subnet that much more specifically. Now, to be fair, in this instance, AnyTrusted and Skynet are kind of synonymous at the moment, because there's only one trusted interface configured. Right? So AnyTrusted is the one trusted interface that I have configured, which is Skynet. But in the thought process and perspective of, well, what if we build, what if we grow, what if we continue? If I leave AnyTrusted and later I make another trusted, did I mean for it to be included in this policy actually? Does it matter that it's included in this policy? Should it not be included in this policy? So on and so forth, right? Just little things about making things as pointed as possible. right? So that's just a random example of a random policy that we might create because you see something that's being blocked, or something that your users need, and because they're originally going to call out because, hey, I can't do the thing, and so you need to talk to them and be like, okay, well, I'll tell you what, let's get an idea, find out what IP address they're coming from, right? Maybe like, right, filter by their IP address. For me, it's not going to change anything really, but. We'll worry about the night. Make him another deny. Okay, so right, and then you ask them, and then once you've got their IP address filtered, you're like, okay, try and do the thing, whatever the thing is, and they're like, bam, and you're like, haha. Okay, right? We're the network guy. We boil it down to what's the IP, what's the port that we're dealing with, what's the protocol we're dealing with, what's the source and destination. Right? This is what I care about at the beginning. Boom. They give you the story, and you get to learn what the cool thing is that they're trying to do, and that's great. But this is what port it communicates on. This is where they're trying to call out with it. Okay, is this a whole bunch of different destinations that's all over the internet? Maybe it is. Maybe they do need any external, and so be it. If they need to go to any external, then you do what you have to do, and you open it up to any external. Because they need to call out to a bunch of different dynamic IPs. Well, so be it. But if they don't need that, then why give that to them? Why open it up that much? So at the very beginning of your security, let's start with conscious policy creation for each port. So imagine at the end of the day, all that a policy is a port or a range or series of ports. Right? And then what direction that traffic is going or anything of that nature is going to be defined as by the from and the to field, the source and the destination of the traffic. But at the end of the day, a policy just boils down to, hey, we're telling the firebox that we want to do something on this port or range or series of ports. Okay, and if we don't have an explicit policy that says to do something on a given port and protocol, then we have some default policies in the background that deny it automatically. Be like, okay, the user has not specifically said that we can do this, therefore no. Right? Very simple, straightforward. So when you're going through here, like HTTP, just for kicks, what I might do is, remove any trusted and any optional and just put Skynet. Because really, in the real world, I might need DMZ and I might need GuestNet. But I could also make separate policies for those two networks if I so chose. So I'm just going to start with Skynet because realistically, that's the only network that I have a node hung off of. So this is the only network that I need. But I do want to go to the whole internet. So I do need to leave any external. Right? So maybe I'm just narrowing a little bit at the source. HTTPS, same thing, right? Remove this a bit. And this is just all that conscious policy creation. I mean, you can just kind of go through these and practice that mindset of, okay, well, where do I want it right now? My management policies, this one I gets a little bit touchy on, and I'll tell you, we'll dodge that for now. We'll come back. Ping, right? Maybe ping I do leave. I'm like, any trusted, any optional, I'm going to make sure that anybody can ping. Anybody needs to ping can ping. I don't really care too much about that policy. DNS, here's a really good one. So what does your DNS environment look like? Do you have a private DNS server? Because if you do, let's think about how that works. That means all of the clients, even all the 57, 157, 757 client computers that you have inside your environment, if they want to do a DNS lookup, they would be calling to the DNS server that lives inside your network. So all of the client DNS lookups have nothing to do with the firebox, are not going to the external world at all, which means the source of this one, the only device that would actually be doing internet-bound lookups at that point would be your DNS server. So if I have a private DNS server, right, 10.0.200.53 maybe, then all my clients would just be internally calling to that guy, and this is the only device that's actually trying to send traffic out to do DNS lookups. But do we need to open it to the external world, to the entire internet? No, we do not. What are the DNS servers that we have defined for our environment. I made an alias for them, right? INET DNS servers, that's 8888 and 8844, because those are the two IP addresses that I defined in the WINS and DNS information for my Firebox globally. My Firebox is the only DHCP server I'm using for the one network that it's handing out IP information on. It's using that globally defined DNS information, which we see here is 8888 and 8844. So really, that's as far as we need to open port 53. Port 53 is a very dangerous port, right? Everybody needs port 53 open, and the bad guys know that too. Okay, they love sending out malware and command and control requests on port 53 because everybody needs to leave port 53 open. And so how many times do I see port 53 just open to any external IP? Man, you can call it to port 53 anywhere you want to. Sure, have a ball. Are you kidding me? Like, we need to make sure that we're really taking conscious thought about, okay, well, where are we aiming this traffic? Why do we need this open? And that's going to secure us down right from the jump. Okay, so we've got that, right? And now I'm just kind of narrowing these policies. Boom, 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 boom. We've put some good thought into it. Now we know that we need to be monitoring so that we can pay attention and see. Ooh, Java. There it goes. We need to be paying attention to when we're seeing traffic that's denied, or when we're getting tickets for people that are getting traffic denied. And I mean, just seeing traffic denied doesn't necessarily mean that I'm automatically like, ooh, this is being denied. Here, I'm going to open this up. Huh? Have I gotten a call? Has somebody complained? Then I'm nope, I'm not going to open it, right? This is a little bit of turmoil, right? I get that. But this is how we provide ourselves a secure environment, and it lasts for, 2, maybe 3 business weeks that you have to deal with some tweaking. Okay, so we see port 9001. So when it comes to my policies, okay, I'm going to talk about the difference between packet filters and proxies tomorrow. I'm just looking at how we move the traffic right now. Okay, so, and which means I'm just going to stick with packet filters because packet filters are the more simple. They're the less intrusive. They cannot do content inspection, so they cannot see as much. They do not provide as much security. But a packet filter and a proxy are both policies. At the end of the day, a policy is just a port or range or series of ports. In any of these things, I can edit all of this information except for the port, except for the port and protocol. I can change the source, I can change the from, I can change app control, I can change IPS, I can change NAT, I can change scheduling, I can change everything except what port and protocol I'm defining this on. Right? That's a packet filter. Same thing. I can change my rule set, app control, IPS, I can change all of this stuff. Not what port and protocol. Right? So that's really the defining property of any policy. So now we've got a policy, that we've got a packet filter. We're like, okay, so you can always, under our edit menu, we can add a new policy, right? Because we're going to inevitably need to add policies. Or I can use my picture icon kind of toolbar here to just add a policy. Or more commonly, right, we can just right-click in blank white space, and I can add a policy. And you'll notice that there's going to be a modify policy, right? Under edit, there's modify, and there's add and delete. So we've got modify and add and delete, and we've got add, modify, disable, delete, right? So disabling, yeah, it's not even listed in this one. Okay, so we don't even have disable here. But disable, I can just right-click, and as we saw with my outgoing policy, it just kind of turns it off without actually deleting it. Now, to be fair, in the real world, you only want to use this disable if it's a very temporary thing, right? If you know that you no longer want that policy, just delete it. Right? Get rid of it. Keep your config as lightweight as possible. Save space where you can. Delete policies that are unnecessary. I'm just leaving all of this for kind of a historical tracking of what we've done with our configuration over this training. So we've got all these different ways that we can add a new policy, and then once we get into policies, right, it gives us the option between packet filters and proxies. And proxies are very protocol-based. There's a few proxies that we have, and we're going to talk all about them, right? But if you just have some random obscure port, like take 9001 as an example, right, then packet filters are likely going to be what you're going to apply to this traffic as far as opening it up. And as we already kind of talked a little bit about, packet filters are less secure. They're the least secure of my policy options. Between packet filters and proxies, packet filters are the least secure. And so if I'm opening that up, on some obscure port, I really want to make sure I've got a pretty good idea about that source destination combination so that I know how much I'm opening it up and for what reason, and that it's justified. So what the Firebox is going to give you is templates, if you will. We've got packet filters, and these are all predefined packet filters that you can select from. And again, at the end of the day, a packet filter, a policy, is just a port. It's got a friendly name on it so that we can see HTTP is for port 80 and HTTPS is for port 443, right? But it's just a port or a range or a series of ports or a protocol that can be applied, right? TCP 25. And so at the end of the day, that's all that a port is. And so you can go digging through this list and hope that maybe you run across a template that's for port 9001. And for some of the more common protocols, because you'll even see that there's an any policy saying you can make a policy that literally is for any port and any protocol. That's even more open than this, because this is just any on TCP UDP, which is 2 protocols. This is any port on any protocol. So it's even more open, right, that you could potentially use. And for any of these templates, you just double click on it and imagine that you're like taking a copy of. Right, that this is the template, can't be overwritten. You just get a snapshot of it, a save as, and you can create your own, and you give it your own name, and then it applies it. But the only thing that is not configurable is what port protocol this policy will handle. Now, we don't have a policy for port 9001 here. We don't have a packet filter for it. We don't have a proxy for port 9001. And under this custom, there's nothing listed. That's because the way that you get custom is by creating a new policy. So it's a little confusing, so that's why we try and dial this out, but these are templates, and if you highlight a template, really you can just double click on it, and that's the easiest way. But the mechanism, a lot of people want to try and click on this, highlight this, and then they click new, like, oh, I want a new one of these. But this is actually doing something totally different. This is making a totally new policy template. If you want to use an existing template, you click on the add button down here. It's not the most intuitive. They're actually working on a change in the user interface right now to make this a little bit more straightforward. So it'll be even nicer as we move forward. But nonetheless, right, these are the templates. If I want to add from an existing template, I'm just taking a save as. This is a copy of. I can name it whatever I want to, make it to from whatever I want to. This is the only thing that can't change, is that it's for UDP 5001 and 5002. Right, and then you would add that to your policy list. I'm going to delete it. So, since we don't have the 9001 listed here, instead of highlighting and clicking add, you'll notice when I close out all of these folders, this goes away. There is no add because I don't have anything selected. So I only have the option of new. And basically I'm making a new policy template. And this is going to go in my custom folder as a new template, right? It's going to be basically a new packet filter or proxy. We're just going to use a packet filter today. I'm going to talk about why that is tomorrow and the difference between them. But we're just going to kind of click on the add button because, again, what defines a policy is simply its port protocol combination. So for our simple example, I just want TCP 9001. And I meant to rename this, which is too late. That's what I thought. Once you've got it created, you can't rename it. So because it's already named. So I'm going to give this a better name, like, how about custom TCP 9001, right? .9001, and put in TCP 9001. So you can select from a single port or a port range, and you can add multiple times. So like if I just have multiple single ports, I can add as many as I want to, right? I'm just adding all the ports that I want encompassed, all the ports that would be encompassed in this particular policy. So we say, okay, and then it creates this as a custom. So really your custom policies are just customly built packets or proxies. So there's only 2 types of policies: packet filters, proxies. Both of them are policies. Now that I've got this as a template, again, you'll notice the add button is back, or I can just double click on it. And then it kind of gives the name here, then I can kind of change it to be whatever I want to, right? Like we'll call this so I've talked with them, and they're like, oh yeah, we've got this data backup that we push over to our co-location, and we just need to make this data dump once a week, right? That our entire department needs to push data over to our colo. It's like, oh, okay. So does your entire, is that all your workstations in your environment in your department that are making that data dump, or do you all send it to one central location and then from there send it over to the colo? Or oh no, we each send directly. Okay, wow. So that means that you've got an entire department of workstations. So right? I might want to. I could either say just Skynet, because it means a bunch of computers coming from Skynet, or I could have them maybe on a VLAN that I can be more specific with, or I can figure out what all their IP addresses are and put DHCP reservations for them and build them into a group that I can alias so I can list from that particular department. Right? There's lots of ways that I can group them organizationally so that I can then list them specifically in the from field. I can just type in each of their IP addresses manually, right? However you need to in that from field. And then two, again, they're like, not to any external. We don't send this stuff all over the place. They're just sending it to our co-location. So maybe it's add and add other, and we get to use a fully qualified domain name, like, colo.voltroninc.com. And that's where it dials out to our co-location. Because that's where they want to go for this port to be open. Right? And then do I want my logging? Heck yeah. I definitely want to know what's going on with all that traffic, please. Thank you. And we can allow that traffic to pass. So all of these are just different ways that we can just allow the traffic to flow between interfaces. So when we say that in order for traffic to be allowed to traverse any two interfaces of the firebox, mostly what we've been looking at here is coming from a trusted network going out our external network to the internet. But what if, let's complicate things even further. What if my DNS server is not 10.0.200.53? But my DNS server is in fact on my DMZ network, which means my DNS server is 10.0.2.53. So all the implications of what that means. That means that first of all, I have traffic, or I have DNS traffic that now all of my internal clients that are on this 10.0.200 network, Skynet, need to be able to send DNS requests over port 53 to the internal DNS server that resides on a different interface now, that resides on the DMZ interface. So I've just separated, right? All my clients are on this network, and suddenly my DMZ server is on this network. So this is what I call sideways traffic, because as it stands right now, there is no port 53 traffic that's allowed to go from Skynet to my DMZ. So we have two options. If you want to keep this separate, which there will be reasons you'll see down the road for application control purposes, and if you're going to get into proxying purposes, that you might want to keep this separate. But I could also just make it as simple right, that this DNS policy, port 53, TCP UDP, is not only open coming from my DNS server to the external world, well, not just the external world, but the two specific DNS servers, 8888 and 8844. That's fine. So my DNS server can still talk to the internet, right, on those two servers successfully. But also I'm allowing, if the source comes from a 10.0.200 address, and it's destined for the DNS server, which resides at 10.0.2.53, then we let this traverse between interfaces, right? This arrives at the Skynet interface, and we retransmit it out the DMZ interface, because this server, since it's on the 10.0.2 network, it would be ARPing to the DMZ interface of the firebox. So the firebox would actually physically know exactly where this node resides. It would have this node's MAC address because it's on its local network, and be able to say, oh, you want it to go there? Okay, we now have the policy that says, yes, you're allowed to do so. So here, I'm going to send it because I know right where that device is at. So you could do it this way, where I just have, all of it built into one policy. Or I could add a policy, and I could, come in here to my packet filters again and grab DNS and say DNS dot clients to server, and say, Skynet, and I'm opening it up for, really, I don't need to give them access to everything on the DMZ network. Maybe I want to. Maybe I want to give them access to all the different servers. But for the most part, even if I want to give them access to all the different servers, the likelihood is that I want to give them access to all the different servers for different ports, so I would still only open individual ports to individual servers, right? That you can use port 53 to this server. If you want to use our internal FTP server, you can use port 21, but it can only be to the FTP server. I'm not going to let you try an FTP to my DNS server, so on and so forth. So you kind of build all that out and separate your traffic, right? And then if you want to see a log of that traversing and any sort of good reporting, we click those boxes, and now you'll see it just kind of builds your DNS policies. So when it comes to the packets moving through the firebox, precedence is everything. Okay, precedence is going to exist in pretty much every list that we have, but it's especially going to be relevant in our policy list, right? Anytime a packet arrives at the firebox, it's going to arrive at the firebox, and it's going to go through this list that it's looking at here. Actually, and I apologize, we kind of skipped past this, but first, before we even get to policies, the very first thing that a firebox does to process any packet that arrives is it goes through this default threat protection schema. This default threat protection includes our blocked ports, blocked sites, and default packet handling. So these items are looked at before we even compare a packet against policies. So that means that these blocked ports that are listed here, right, we give a handful of obscure blocked ports. It may be that that's okay. It may be that you need to remove some of these to allow them for whatever your individual business purposes are. But these are listed here, and if you try and use one of them, you will see a log message to indicate that. Interesting. I would have thought that gave it an internal packet. All right. Well, I'll make a note of that. Usually it fires off a different error message for that. So I'm not sure if they just combine the error messaging or what. I'll double check there. But this is the first list that gets compared against. Before we even get to a policy list, right? This is a first port list that is compared against. So I don't care what your policies say. If it's on this denied ports list, this blocked ports list, then we will not pass traffic over that port. Kind of same thing with the default threat protection, the blocked sites. So everybody hears sites and they think website, right? And we've had this around for a long time. Site is, what we mean by that is an IP address, a host, a node, because a source or destination. But we're going to translate that down to an IP address or a group of IPs or network of IPs, and that will not be allowed as a source or a destination IP address for any packet to be processed by the firebox. So this is not the place to go if you want to block it. As much as we have everything from host IP address to network and range all the way to fully qualified domain name, this is not where you come to block playboy.com. Right, because that's something that you do on port 80, on port 443. That's something that can be handled in our proxy. We have way better means for this. What this is more meant to do is if you have a a site that is known bad site or known problematic site or whatever it might be, that this is a bad site, something that is bombarding your firebox or something that is problematic, then by putting this here on the blocked sites list, this IP address will not be allowed as a source or a destination IP address of any packet on any port using any protocol at all, period, right? It blocks everything. It blocks that IP address completely. It's not about protocols or source or what it's doing or web address versus, just random TCP call out. Nope. Will not accept this as a source or destination IP address on any packet, period. So it's a very global block list. Then, of course, there's going to be all sorts of actions that can occur that will cause for a site to be put on the blocked sites list. We'll talk about all those actions. We're going to look at all of those actions. If something happens as a false positive, we can add entries to this blocked sites list, right? You'll see that there's a whole bunch of analysis and kind of exceptions that we have for some WatchGuard and some management cloud sites that are all for WatchGuard use, and are kind of listed for why they're here. But you can always add additional exceptions, right? If you want to make an exception for any computer inside your network. When it comes to all of these block actions that we're going to be able to take for all these different reasons, right? We're going to see all of that in tomorrow when we're looking at proxies and we're looking at antivirus and all these different things. We're going to have the ability to quote unquote block a device. Block means to put them on the block sites list. To take the source of the traffic in question, the source of the transgression, and we're going to put it on the block sites list for a temporary period of time. The default is 20 minutes, right? You can define that all the way up to 99,999 minutes. I believe the technical term for that is a really, really long time. But nonetheless, for all of these actions that you take, for any of the actions that are going to be listed in any of our policies or antivirus or services that we have, anytime you take the action to quote-unquote block, it is always a temporary block. It will always start a counter clock, and then it will take them off the block sites list after that counter clock expires. The only way to globally, permanently block an IP address on the firebox is through putting it on this block sites list. Right now, Rob asked a good question, right? Why not just make a policy that's in any policy for any port, any protocol, and say from, any to 76.76.76.76, and then maybe even a deny policy that says from 76.76.76.76 to Firebox, right? So that it can't call on any of your public IP addresses as a source either. So the only real benefit, because that works perfectly, fine, absolutely, that would do the trick great. You might have to play with some policy sorting to get everything in the right order, so there's a little bit more maintenance there. And if you think about the order of operations, this is actually checked first in the processing. So by putting it here, we're just dropping it earlier in the processing of the packet, meaning we have to go through less overall processing in its entirety, right? That overall there's less processing happening because we've found the solution earlier in the equation. That would be really the only difference there and the benefit of using this global block sites list. And that's kind of what its purpose is. First, we're just double checking. Is this a IP address that we allow? Okay, great. Moving right along, right? And because it's off a short list, it's a very short, quick check. But if there is something there that you are wanting to deny against, you can just shut it down, and then you don't have to worry about making two individual policies to stop both inbound and outbound. Because if I'm hosting other things, I might be hosting from any external, which suddenly includes that 76, 76, 76, 76, unless I have a policy specifically stopping inbound from that IP, as well as stopping outbound to that IP. So just a little bit less to do, I guess. Your thought process was sometimes when upgrading or replacing firewalls, you can't do a direct XML file upload, and that could get easily forgotten. It is true, it could get easily forgotten. And overall, there should be, well, I mean, I don't know exactly what all they have there, but yeah, if you can't get the XML config imported, that makes it a bit more challenging. typically at that point, what I'm going to do is I'm going to open the old config in WSM and try and use that as best I can as my roadmap to rebuilding a new one from scratch kind of manually. And I just kind of click through all the sections. But you're all right that means that it's one more place that could be missed. So we say OK here, and that's the very first things that get a packet get compared against, right? Is the block ports and block sites. Then we have these blocked packet or default packet handling thresholds, and you'll notice for like all these drop actions, they're flood attacks. And they're for all these different protocols: IPsec, ICMP, SYN, UDP, and it means once a connection is established, if we receive X number of packets in a given second from on a single connection, we're going to drop that connection, right? That's a flood. Like, okay, whoa, sending us way too many packets. Now, this may need to be bumped up for some environments. You might be able to bump it down for some environments, right? You can kind of play with that and tweak it either way for your Firebox, but that's configuration that you can make, and it's just a flood attack against those individual protocols, ensuring that we're not going to deal with, a packet overrun. The only two things where we take the block action, where we're first introduced to this block action, is for IP and port scans. And this is one that could potentially have some false positives in it, depending on what your mail situation is. So, block port scan, this is just saying that if you try and hit 10 different destination ports from a single source IP address in a single second, we're going to put you on the block sites list. The source that tried to hit those 10 different destination ports in that single second gets put on a block site list. Now it can't talk to the Firebox at all on any port using any protocol for 20 minutes or whatever time frame we configure. This one is IP scans. If a single source IP address tries to talk to 10 or more destination IP addresses in a given second, we're going to put that source IP address on the block site list. What if I'm an e-commerce company? Email is how I do my business. That's how I sell my product. That's how I advertise my product. That's how I buy my product. That's how I support my product. That's how I sell my product, right? So, everything there is through email. And I'm a very large, successful company. What are the chances that my email server that I host here behind my firewall might send 10 emails to 10 different destinations in a given second? Maybe not every second, but on a busy day in a given second, 10 emails to 10 different email addresses, right? That's 10 different destination IP addresses coming from my mail server, which is one source IP address, in a given second. Suddenly my email server just got put on my block site list for 20 minutes. That's no good, right? Now my email server is not sending email or anything else for that matter for the next 20 minutes. So this might be one of those points where I'm like, okay, instead of raising the threshold, if my email server is the only one that's really breaking this threshold, then maybe I go put my email server on my block site exception and leave the threshold alone. So just different ways you can handle that. Then once that's done, now you get to your policies, and it goes through the policy list in order. So if it's that policy for 9001, first it's going to look at this policy and be like, not the right port, not the right port, not the right port, not the right port, not the right port. This is the correct port. Okay, well, I'm coming from 10.0200.201. Okay, well, that's an IP address within the Skynet alias, and I'm trying to call on colo.voltroninc.com. I'm just putting that so we can actually see I'm cheating a little bit so we can actually see a log go out for it. All right, but you can see that we've got the logging turned on for that policy. Great question, Paul, and absolutely, I'll show you here in just a quick second. I did do something weird. I was like, what's going on? That's right. I killed my own DNS, right? But I mean, you can see it in the log lines that I'm coming from 201 trying to go out, but I limited my DNS for real, which that's not going to work, right? Because I'm not that DNS server. So suddenly I closed off my DNS port. That will work. So, I mean, in the log lines here, you kind of see that I'm looking, and there's all these little filters within my traffic monitor. I can look at all logs. I can look at traffic logs, alarms, events, debugs, statistics. And so you can see these are event logs where I can see my user logged in. And so if I filter by events, this is just my management user logging in and logging out when we're making changes, things of that nature. If I just want to see traffic, you can kind of filter by just traffic logs and so on and so forth. So now I've got my DNS back. And we can see that it was being denied there for that short while, and now we've got it returning and coming back. Like we would normally want. There we go. And so now let's try. Right, and there it is. We can see data backup to Colo, port 9001. And of course, we're not going to really get a response out. But I mean, we can see that we're now allowing it through the Firebox. The Firebox is passing it on, right? Just because the internet's not going to respond to it correctly, the Firebox is still going to pass it on because we've created that policy for it. And we get a log of that traffic, and because it's going to the correct destination. Right? Now, again, in the real world, I would remove any external because we're only pointing to our Colo, but this just gives you a feel of what that kind of looks like, that we'd be like, and now you look like a hero because everyone's like, oh, it works now. You're like, perfect. And so you just have to go through some of the growing pains of dealing with that and opening those ports and creating those policies to allow that traffic and trying to narrow those policies as much as possible. I promise. Most of the time, you'll find that the story they give is, even if it's some obscure port, it's likely not that they need to go to a whole bunch of different places. It's likely that they'll be able to give you a fairly focused endpoint of where this connection needs to dead end, right? And that will often be a fairly consistent place. It's not terribly often that we run into. It's not as common that we run into. Oh, we need port 10,800 open to everything. It's like, oh, you just don't even know where you're going to have to call? Nope, it's going to have to dial to everything. There may be some things that have to do that, and then you have to determine and be like, wow, it's a lot. Okay, what are we doing with that? Why are we doing this? And then, it's like, okay, sounds business critical. Here we go. It's now set up, right? Port 10,800 can now send traffic from our trusted network to anywhere. Ouch. Right, but if it's what needs to be done, it's what needs to be done. All right, I think that pretty much wraps us up when it comes to just policies themselves. Let's see here. So I see a question: if you create a policy in Firebox number 1 and select, say, 20 IP addresses as its destination, is there a way to easily add just that same policy to Firebox number 2? And Firebox number 3 instead of having to manually enter those same 20 IP addresses? Yes and no, Rob. So Direct Connect, not as much. I mean, short of cut and pasting XML, which right, we don't recommend hacking apart configs. So not quite as much when it comes to that specific function. What we can do, however, is if I've got a substantial amount of Fireboxes, if I've got a management server, exactly where Tristan's going, I can totally make a template. And I can make a template and the cool part about templates is those are incremental changes. So I can have like 17 different templates that one template is just within the scope of my dimension logging. So the only thing that it's going to manipulate about all of the configs that I apply this particular template to is it's going to add my dimension server's IP address and authentication key. And then I can have a totally separate template for what you're maybe talking about, Rob, that's got, this 20 IP addresses for its destination of this place that it needs to go, and it's the same policy that I need to apply everywhere. I just make one policy that's just about that, and then as a template, I can apply that to all of my other Fireboxes, blah, 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 blah. And then it just incrementally changes the config that's existing on all those Fireboxes and adds that templated information to the existing config. So pretty handy. How about that? Let me throw this one back to you guys and kind of open up questions. So Dimension server only. No, actually, this one is more specifically management server, like the old more traditionally WatchGuard management server itself, as opposed to the new Dimension command. They have not quite come out with templating and things like that for the Dimension command yet, but they're working on it. Oh, you run the management server. Oh yeah, absolutely. Then definitely check into templates. Oh man, check in. Yeah, templates are a huge one. In fact, I'll just go ahead and I'll throw a pitch for. We have a half-day course that is centralized management. It does not deal with the Dimension command. We haven't incorporated that yet, and that may even need to break off and be its whole own course. But as it stands right now, management server is still the more functionally rich solution. And that's what is still prominently out there in the field. And so we have a half-day class on management server and how that all kind of goes together and works. And that's definitely a fun class as well. I don't know exactly when the schedule is. You'd have to check on our training schedule to see when that's going to be coming up next. We don't hold that one quite as regularly as this Essentials, but it is another half-day course that we have. So if you're interested or you deal with management server, there's another one to check out. It may not be in the August lineup. That one may not happen every month. So, with that, everybody, I want to say thank you for day one. Right? I try not to go the whole time. Every time I feel like those are pretty long training days to have to sit here and listen to me yammer on. And as fun as I know that this stuff is, it's all very exciting. I get that things can get dry on occasion. So, hopefully, it's been somewhat entertaining and informative here for today. And you're 1/3 of the way done. You have to tolerate me for 2 more days, and then we'll be finished. The only homework that I ever give, right, is any questions that you have, or things that come up overnight. You wake up in the middle of the night from a dream and you're like, WatchGuard, right? Write down that, remember that question, and ask that, right? And I'm here to help, and do the best I can to provide solution. Tristan asks, I see, are our labs going to reset tomorrow? No, this is the block class. So in the block class, you get the same environment for 3 running days. So we get to build more on top of this existing config tomorrow. So everyone save that URL link that I gave you today. You're going to use that same URL to connect to your same environment tomorrow, right? This is yours for all 3 days this time of what's going on. With that in mind, I'm going to be leaving the environment open for an hour after class every day. So if you want to play around, again, I know it's kind of been long days, but if you want to play around after class, you're welcome to do that for an hour. And then tomorrow, I will spin up the environment a half hour before class. So if you want to dive in early and tinker around, you are also welcome to do that. We try and give a little bit of play time to just look around and play. And if you're familiar, you can go ahead, and if you break something, we'll figure it out and fix it, no big deal. And then, questions and things along the way. Tomorrow, I'm going to talk about some of our services. I'm going to talk about network address translation. Those are going to be first thing in the morning. And then pretty much the rest of the day is going to be proxies, right? How all of our proxies work and how the services and securities all fall in. Let's see here. For those that are using different policies for groups of users, how are you setting that up? Assign static IPs and assign them to groups, but I feel like there must be a better way. There definitely is. Authentication is definitely going to be the way. I do authentication on day 3, so we'll talk at length about how that all works. Yes, you can authenticate against Active Directory, or Radius, or Secure ID, or LDAP of any other flavor, or the Firebox even has its own internal user storage where you can build local users and groups if you don't have a third-party authentication server like Active Directory. So there's lots of solutions there for you in the authentication side that we'll look at. And that's definitely going to hit us in the beginning of day 3. Let's see here. Unfortunately, I don't have. Let's see here. Is there a specific way to properly exit the VM? No. The VM will close itself on its own. The VM will definitely fall away. And unfortunately, I don't have any additional or temporary keys that I can really give out for the environment. This is more along the lines of just these training keys that kind of play for these internalized devices. So with that, I really appreciate it, buddy. Thank you very much. I appreciate the interaction and the questions and the the engagement, right? That makes all the difference in the world when it comes to doing one of these. Talking into an empty room with a microphone, it's nice to know there's someone out there on the other side. So I really appreciate the engagement. Thank you much, everybody. And again, tomorrow morning, let's see, goodness, we'll do it 8:30 a.m. Central Time. I'm in Pacific, so that means 6:30 a.m. my time, 6:30 a.m. Pacific, 8:30 a.m. Central. I will have all the environments spun up, and then 9 a.m. Central or 7 a.m. Pacific, we're going to be kicking off the class again. And the second and third day, I don't really give much leeway. I just kind of roll right on through. The day 2 is usually the busiest and most filled day. So that's what we'll tackle at that point. Thank you again, everybody. I really appreciate it, and we'll see you again tomorrow. Same end time tomorrow. Yeah, same end time will be right around this time tomorrow. Thank you much, everybody. I appreciate it. Paul F. It may go a little bit closer to the 3 o'clock. Tomorrow is the most full day, but it's somewhere around between 2 and 3 p.m. Pacific time here that we have this virtual time. But yeah, somewhere around this time. Take care, everyone. Have a good night.
Hello?